So we're going to wrap up Chapter 8 today, and I'm going to go back to screen sharing. So let me do that. Okay. Push this here. So last time we were working through an Excel sheet, this Excel sheet looking at a firm. And so I'm going to do, because I don't need the whole period to finish up what we need to cover, I'm going to kind of go back through it again. I won't do all the details, but I want to walk through it again because I just want to make sure you all get the concepts. So we have, when we do our variance analysis and our budgeting, which is what this chapter is about, we start with the static budget, and that's the phrase we use to refer to the budgeting exercise that we do before the beginning of the fiscal year or quarter or whatever it is, right? So the static budget is what we think we're going to do, what we expect to do, both in terms of volume and in terms of price or cost. And so the static budget, what I jot down here is to just remind myself is the static budget is the expected volume times the expected price. And that price applies whether I am talking about a cost or a price in the sense of a price I'm paying, or a price in the sense of the price of something that I'm receiving. So like our revenues would be a price. Okay, so then the first section of the budget is going to be our statistics budget. And the statistics budget is basically the numbers, right? The numbers, statistics meaning numbers, right? So the number of capitated lives, for example. So that tells you that this clinic has at least part of its volume is generated by capitated lives. What is a capitated life? We've talked about this a number of times, but this is basically a contract with an insurance company and the contract basically says, provider, we will give you some payment, some fixed payment, right? So your revenue in the case of capitation is fixed. So provider, we will pay you some fixed payment, typically in the form of a per member per month payment. And in exchange for that, we expect you to provide all of the care within a particular scope. So if this clinic was an outpatient clinic, it might be, hey, for our 8,000 capitated lives, we expect you to provide all of the outpatient services for our 8,000 employees. And if they, and we're going to pay you some amount for that. And so you get that fixed payment, right? We did this last time where it's a fixed payment. So it becomes, if we're going to draw this on a graph, it would be a horizontal line because it doesn't vary with the number of visits, right? If we were drawing revenue versus visits, well, we get the same amount of revenue regardless of the number of visits. So the contract is a fixed payment regardless of the number of visits. So in this case, they've got 8,000 capitated lives that they're going to receive this per member per month payment for. Then they have a utilization rate per month. So this is an expectation that for every capitated life, they will on average use 0.18 visits per month. So that's what their utilization rate is how much are the patients going to utilize the care that is how much are the patients going to utilize the clinic? And so the expectation is 0.18. Now, obviously, you can't, nobody can have 0.18 visits, and so it's an average, right? And so if you said, well, how many visits is that going to be? If I was a capitated patient, how many visits would that be per year? Well, this is a per month rate. So to figure out what that is per year, I take 0.18 times 12, and I get an average of 2.16. Okay, so I still can't do 2.16 visits per year. But if you add up all the people, some people are going to do 2 visits, some people are going to do 3 visits. So it looks like on average, people are closer to 2 visits than 3 visits, but that's the average. Maybe some people just do 1 visit and some people do 4. It's hard to say. Okay. So we take our 0.18 visits per month on average, and we multiply it by our 8,000 capitated lives, and that would give us 0.18 visits per month times 8,000 visits gives us 1,440 visits per month. But we're really interested in an annualized number because that's how we do budgeting typically, is on a fiscal year. So we're going to take 0.18, the monthly utilization, times the number of number of lives, times 12 to give us our annual number of visits. So it's likely on the exam that I won't give you the number of visits for the capitated patients. I might expect you to calculate that, but you should know the relationship between for capitated lives for under capitation is this relationship between the number of lives and the utilization rate, and then of course it could be given to you in a monthly amount, and then you need to also remember, okay, it's probably going to be a per member per month rate, which we get into down below. So now to complete the statistics budget, we need to know, okay, we're not just a capitated clinic, so we're not closed to non-capitated patients. We're also seeing fee-for-service patients. And in fact, it looks like we're seeing more fee-for-service patients than probably capitated patients. And so you have 17,000 visits generated by your capitated patients, 35,000 visits generated by your fee-for-service patients. And that gives you a total number of visits of 52,280. Now over here on the right, we have the actual column, and this is where we're putting in what we know after the fact. So the static budget is what we think is going to happen. And so these are our estimates going into the year. So if our fiscal year starts in January 1st, this static budget is probably finalized in early December by the board. So the actual is going to be the actual number of capitated lives we had, the actual utilization rate, as a result, the actual number of capitated visits, and then the actual number of fee-for-service visits. And we're not going to know that until after the end of the course of the year. So we have our estimate, and then we have our actual. Now the flex mixes the two together to allow us to do some comparisons and do our variance analysis, which we have over here. So I'll get to that in a second. So then we go into the revenue portion of the budget, or the revenue budget as your book calls it. And because we have two different kinds of patients, because we're selling our services to patients in two different ways, we're going to break our revenue budget up into two different sections. We're going to have our fee-for-service revenue and our capitated revenue. So starting with the fee-for-service revenue, because it's simpler, we projected that we would earn $75 per visit for our fee-for-service patients. We projected 35,000 visits, which we pull from, and you'll notice I'm using, when I build my spreadsheet, I try to build my assumptions once. So if I have like a volume assumption, I try to put it in one place. What that allows me to do is manipulate my model. So this is essentially creating a model. So you can see that equals B8 here means I'm pulling that 35,000 from the static budget and dropping it in here to get 35,000. If I was to go change that, if I was like, maybe instead of planning to have 35,000 visits, I think I'm going to have 37,000 visits. I could just change 37,000 once, and what it's going to do is it's going to carry through down here, and it'll change my fee-for-service revenue, and it'll also change my variable cost per visit, because that is including, that's pulling the total number of visits from up here in the static budget. So if you do this properly, let me see, do that. If you do this properly, in the sense of you're setting up the model properly so that it refers to, back to the same set of cells, you can very quickly manipulate the model and manipulate your assumptions. So that's something you need, that's a skill you need to build, regardless of whether you want to go into finance or not. Excel is used all the time in operations, it's used everywhere in business. So this is a skill that's not finance specific. Okay, so we wind up with an expectation about our fee-for-service revenue that's going to be simply our price times our quantity. Right? That gives us our expected fee-for-service revenue. Our actual fee-for-service revenue, we actually earned $77 per visit, so we earned more. We had a higher price than we expected, but we had fewer visits than we expected. And so we have this mixed outcome where we thought, where we underestimated the revenue per visit that we would earn, but we overestimated the number of visits that we would earn. And so that nets out to a slightly lower total fee-for-service amount. So now we can compare across our fee-for-service values, and we generate a flex amount for, and the flex is, so we haven't talked about this yet, but the flex column allows us to compare and get and separate out, disaggregate, or decompose the effects of changes in volume versus the effects of changes in price. And the way it does that is the flex entry has the actual volume, so I might sheet notes up here, the actual volume and the expected price. So this is this kind of Franken number, right, that combines two different things. It's an apples times oranges number. And so by itself, it's kind of useless. But when you combine it with either the static budget numbers or the actual budget numbers, it allows you to do some interesting things. So, for example, if I'm comparing my fee-for-service revenue to my flex revenue, I'm using the expected prices, right? Expected price. And so the difference between these two numbers is a result of the difference between the expected volume and the actual volume. And so we know that our actual volume was lower than our expected volume, and that's consistent with the fact that our flex revenue is low for fee-for-service is lower than our expected static revenue. And so we can quickly figure out what was the impact, the dollar impact on our fee-for-service revenue as a result of the change in volume, holding, and here's where we hold the price constant. And so we can do that by calculating the volume variance, right, which would be the flex revenue, fee-for-service revenue, minus the static fee-for-service revenue. And so we can see that there was a $150,000 difference between the expected fee-for-service and the actual fee-for-service that resulted from the change in volume, holding the change in volume constant. Just turn this column over here. So that's the difference between the static and the actual is explained in part by the change in volume, but it's also explained by a change in the price. And so if we want to figure out, all right, we think 150,000 of this is the result of a change in volume, what was the dollar effect of the change in price? Well, the price is actually higher, and so we would expect to see a positive variance for that. And to get that, we compare the actual, which has versus the flex. So in this case, between actual and flex, they both use the actual volume, but the actual column uses the actual price and the flex uses the expected price. And so we're holding volume constant and varying price. So if I take the actual minus the flex, I can see I had a positive impact from the increase in price, but a negative impact from the decrease in volume. And if you look, you say, well, 2.6 million versus 2.5 million, that's about a $100,000 difference, and you've got 150,000 here. Well, you're right, because the volume pulled it way down, but the change in price brought it back, offset some of the down of the volume. And so if we add these two together, we get a change of 84,000. And so if I just compare the actual and the static, you're going to see that it was 84,000. So what we're after with this variance analysis is to explain this 84,000. So this 84,000 is the result of two different forces acting on our clinic's revenues. On the one hand, we had a significant decrease in revenue, as a result of our decrease in volume. So that pushes our revenue down, but at the same time, we earned more per visit, and so that pulls the revenue back up again. Now, as it turns out, the volume had more impact than the change in price. But what's useful about variance analysis is we can now see that, as opposed to before we could just look and say, well, there was about an $84,000 difference, and we're not really sure what, and we can kind of eyeball it and say, well, we see we had visits were down and price was up, so it must be, kind of this, you can intuit the result was, volume was going to drive the price down, and volume was going to drive the revenue down, and price was going to drive the revenue up. But this gives you the actual values. So that's what's useful about that. All right. So we've done kind of a both revenue volume variance and price volume variance on the fee-for-service revenue alone. But that's not the bigger picture. The bigger picture is this clinic didn't just have fee-for-service revenue, it also had capitated revenue. So to calculate the capitated revenue, we take the 8,000 capitated lives, right? So remember, I'm grabbing that 8,000 from up here using an Excel formula, saying, okay, I'm going to use the same 8,000 that I had up in the static budget down here. And wherever I use that, wherever I need that 8,000, I'm just going to hit equals B5, right, and have it drop in there, because that way, if I decide to change my assumption about capitated lives, it'll feed through my whole estimate. So I had 8,000 capitated, an expectation of 8,000 capitated lives. I actually had 8,200. So they thought they were going to have 8,000. over the course of the year, they averaged 8,200. So they had an increase in the number of capitated lives. They had a per member per month, so they had a contract with the insurance company to pay $20 per member per month. And remember, the capitated revenue is not tied to the actual number of visits that the capitated patients do. It's completely independent. So the capitated revenue then is a function of the 8,000 capitated lives times the $20 per member per month times 12, because 20 times 8,000 would give us our monthly income from the insurance company. And so in order to get that to an annualized amount, you have to multiply that by 12. And so we can see here that we had an increase in the number of lives, but the same per member per month rate. So when we calculate revenue, so unlike when we do fee for service, where we're taking the price per visit times the number of visits, so volume, in this case, for fee for service, is the number of visits, and price is the price per visit. When we calculate the volume times price for capitated revenue to get our for capitated patients to get our capitated revenue, we're not going to multiply by the number of visits. Volume in the case of capitated patients is the number of capitated lives, and the price is the per member per month, right? Because we don't get paid on a fee for service or on a per visit basis. So you have to be able to reframe what volume and price mean depending on where you're at, or depending on what kind of patient you're talking about. Okay, so we had.
I have a question about that payment.
Yeah, go ahead.
Does that come like in the bulk payment for that fiscal year? Like, would the insurance company give that 1.9 million to the hospital because they know that they're going to have 8,000? They estimate that they're going to have 8,000 capitated lives. So going into that fiscal year, they give them that money, and then what happens if they have 8,200? Now they're short that money, or does it come as the visits come?
No, it doesn't come as the visits come. It would be on a periodic. It would probably be on a monthly basis. They would make adjustments on a monthly basis. So in reality, there aren't a lot of pure capitated contracts out there now. What instead we have are value-based contracts where it's a little more complicated. It's actually more complicated than what we're presenting here, but it's a variation on capitation where, say, so with this example, I would expect them to give you a monthly check, right? That reflects the number of patients that you're providing under the capitated contract. So the contract would be $20 per member per month. Okay, this month we had 8,000. You know what? Next month we have 8,100. The month after that we have 8,200. The month after that 8,250. So that it averages out at the end of the year to 8,200 over the course of the year, which would be what we're capturing here. But it might be 8,100, then 8,150, then 8,100, then 8,300. Like there might be some fluctuation.
Do they run on like an estimated budget though? So like if they, like would the hospital eat the cost for that month and then just get back pay from the insurance company?
Yes.
Okay.
Yeah, exactly. And I think what's interesting is if you hear about value-based payments, which is more common now than pure capitation, you would have an arrangement with Blue Cross or Harvard Pilgrim, for example, and they would say, okay, Wentworth Douglas or Exeter Hospital, we think that 8,000 of our patients are reliant on your practice on your physician practice for their care. We're going to look at their total spend over the course of a year, or over the course of, it's usually a year. It's an annual contract. We're going to look at their total spend over the course of a year. And if you can keep the total spend down by keeping them healthier, then we will give you a bonus, or we will give you a portion of the savings. So this is called a shared savings contract. But if the total spend by our patients goes up, and it doesn't matter whether they're coming to Wentworth Douglas or whether they're going, to Boston Children's or Mass General for specialty care, if it goes up, if they have the most aggressive form of these value-based payments is if the total spend of our patients goes up, then we penalize you and we take some of that money back, or we don't pay you as much of a bonus as we could have. So maybe we say there's a standing bonus of $150,000, and we expect the total spend for our 8,000 patients to be $1 million a year. If you can reduce that total spend by, and if you hit $1 million, we'll give you that $150,000. If you can cut below 150, if you can cut below $1 million, let's say you get that total spend down to $900,000, maybe we'll give you 20% of the savings. So we'll give you the 150,000 plus a kicker of 20,000, 20% of the $100,000 that you saved. However, if our 8,000 patients spend $1.1 million, and it's not necessarily at your facility, it could be that they get referred out for specialty care at a facility that you don't run or a practice that you aren't responsible for. If that spend goes up to 1.1 million, then we're going to penalize you and take back from your bonus 20% of the overrun, or $20,000 in that case. So instead of getting a $150,000 bonus at the end of the year, you're going to get a $130,000 bonus, and that's continuously updated, between the practice and the insurance company, and so they kind of keep this running total constantly. And so that's more common today than capitated payments are. Most practices are getting into some sort of value-based model where they have the opportunity to earn shared savings and the opportunity to also potentially share in the downside. It's called downside risk. So you have upside risk where you can earn a bonus, and then you have downside risk where you get a penalty if you're wrong. Capitated is a very pure version of this, where the insurance company just gives you a fixed payment, and then it's totally up to you to manage the spend of the patients. Okay, but that's a little more than what Emma was asking. You were just saying they would get a periodic update over the course of the year in terms of their revenues. That's how it would go, whether that's on a monthly basis or a quarterly basis. It wouldn't be like a one. From my observation, it's not like here's your money at the beginning of the year. Okay, we're going to take some money back, or we're going to give you some more money at the end of the year. It's going to be a more frequent update than that. Okay. So you can estimate, in the same sense, you could estimate how the impact of the change in volume had using your flex revenue and your static budget, and also how the changes in price, there were none. So since there was no change in price, notice that where we held volume constant and varied price, well, if there's no change in price and we're holding volume constant, well, then you're not going to get a change in the values for the flex and actual, right? So they're the same. And that's because we're holding volume constant and varying price, but if price doesn't actually vary, then you get the same thing. So then we add together our revenues to get our total revenue. All right, then we get into costs. Let me pause there for a second. So on the exam, I expect you to understand these relationships between the number of lives, the per member per month, the utilization rate, right? All those things. And so I could potentially give you, excuse me, I could potentially give you, in this case, I didn't give you the number of visits. I could potentially give you the number of visits and the utilization rate and not tell you how many capitated lives. And you should be able to back into how many capitated lives, because the number of visits is equal to the number of capitated lives times the utilization rate times 12. So if I was to give you, instead of giving you these two numbers, I gave you, say, these two numbers, you ought to be able to back into what that number is. Okay? So, and that number is important for calculating your revenue. So maybe I do that instead on the exam. It is not the case that I'm going to necessarily give you this structure exactly. I could give you instead a word problem, right, that looks something like this. So in this case, this is an example where I've given you in the text, right, all the information you need. You have to do some calculations. You have to build that static and flex an actual budget. So don't expect to be handed this necessary, in its, preset for you. And even if you are, chances are I'm going to delete something out of this to make it, to kind of see, do you actually get it? Do you understand what you're doing? So getting into cost, just kind of reviewing again, cost. Cost breaks down, can be broken down into a number of things. So we're going to break our cost down into variable and fixed cost, and then variable cost can be broken down into a number of different categories. And so the variable cost in this case is composed of two components, labor and supplies. And you can see that we had some expectations about labor and supplies, and it turns out we were wrong. And we were wrong. We underestimated both the cost of labor and the cost of supplies. So when we add them together, we can see we thought we would spend 2.32 million. We actually spent 2.34 million. Not a huge difference, but a difference nonetheless. And it's important in order to calculate the flex amount, because the flex amount is the expected volume, the actual volume times the expected price, you need some price to work with. And in this case, it would be with variable cost. Variable cost is tied to the number of visits, right? And so now that we're in cost as opposed to revenue, the revenue, cost is independent of how the revenue comes in. So the cost of providing a visit for a capitated patient is the same as the cost, presumably, is the same as the cost of providing a fee-for-service visit. And so we just lump all the visits together in terms of the number of visits. And we don't break out, the variable cost for a fee-for-service visit was this, and the variable cost for a capitated visit was this. We generally, that would be meaningless because when you're providing care to a patient, you're not going to change how you provide care. You're going to do this appropriate standard of care regardless. So in order to calculate the flex variable cost, I'm going to need my actual volume, which I get from up here. I take my actual volume from up in the static budget, and then I have to multiply it by some price, some expected price. Well, the expected price is going to be the variable cost per visit, right? Because I'm taking visits times variable cost per visit. And so to calculate the expected variable cost per visit, I take the expected variable cost and I divide it by the total number of expected visits. And that gives me my expected cost per visit, which I can then use to calculate my flex budget. So it's important to be able to do that. And here we can do the same process to calculate variances based on volume, right, by comparing static versus flex. And so we can see we expected to spend 2.3 million. We actually, holding price constant, we should have spent 2.1 million. So we should have had a savings of 180,000, something like that. I don't have to guess. I can tell you. We should have had a savings of 157,000, but we actually spent more per visit. So comparing now the change based on price, we actually wound up the impact of an increase in cost per visit generates 173,000 in per visit if you're holding and isolating the impact of price per visit versus volume. And if we add those two together again, we're going to get the actual difference. And they match up, right, when we reaggregate these two. And so we have bigger forces at work than appear on the surface. And that's an important point to make, right? These are two fairly big numbers, right? Relative to the total, right? Those are pretty big variances, and they just happen to offset each other. So as a manager, you care about that kind of thing, because if you've got this big impact from changes in price, but it doesn't look like it's all that bad because you had a decrease in volume. Next year you might not have a decrease in volume, but still have a big change in price, and you'd really be in a world of hurt because you wouldn't have the changes in volume to offset it. So that's important to keep in mind, and that's part of why we do what we do. Fixed costs, again. Fixed costs, we thought fixed costs would be 1.8. Fixed costs we think of as having basically a volume of 1, right? And so that's kind of the best way to think about it. So price, basically it's price times 1. So the expected price was 1.8 million times 1. The actual was 1.75 times 1. The flex is 1.8 because we're using the actual volume, which is still 1, right, times the expected price. So there's no variance there between the static and the flex in terms of volume, but there would be in terms of price. So then we total up our costs, right, by adding the variable cost and the fixed costs. And then that gives us our total costs, and our profit is simply profit is revenue minus cost. All right, so that was a review of what we did last time. So I'm going to run quickly through these variances, and we'll wrap up on costs, which we hadn't finished. So the first level variance, we're going to compare profit variance, right? That's the overall variance in profit. We thought we would have 417,000. We actually had 415,000. One of the common mistakes people make is they say, well, if I say, explain profit variance to me. You had a negative 2,300 profit variance. What does that mean? And one of the most common errors I will get is, oh, they had a loss of 2,300. And that's not true, right? They actually had profit of 415,000. They didn't have a loss of 2,300. They just overestimated their profit by 2,300. So it's important to remember when you're looking at variances that, in particular, profit is not a loss, right? Because they still have a profit, but they had they overestimated their profit by 2,300. So then that profit variance can be decomposed into revenue variance, right, which is the actual revenue minus the static revenue gives us 36,000, and cost variance, right, which is static cost minus actual cost. So let's review that for a second. Notice and remember, when we're doing profit variance and revenue variance, we're going right to left. We're doing actual minus static. When we're doing cost variance, we're going left to right. We're doing static minus actual. And the reason is we want the sign to come out as positive for favorable variance and negative for unfavorable variance. So if I was to go, so I do, like I said, profit variance, actual minus static, I'm taking 415 minus 417. And that gives me a negative number. This is an unfavorable outcome, right? An unfavorable variance. I would, if I'm going to have a variance, I would rather have profit be higher than expected than lower than expected. And so when I subtract 417 from 415 and I get a negative number, it's telling me I have an unfavorable variance. Again, not a loss, but what that negative number tells me is I expected 417. I actually had 415. So I overestimated my profit. Same with revenue. I go right to left. So 4509 minus 4545 gives me a negative revenue variance telling me I overestimated my revenues, right? So a negative revenue variance doesn't mean I had negative revenue. It means I overestimated my revenue. And I do it right to left because a positive variance would be to have more revenue, more actual revenue than expected revenue, but I didn't. I had less actual revenue than I expected, and so I have a negative variance, which basically just tells me I have a negative outcome. I have doesn't mean that I had a negative revenue, right? I still have a lot of revenue. 4.5 million in revenue is a lot of revenue. I just was off by 38,000, I think was the number we said. Costs, we go in the opposite direction. We take cost, we take static cost minus actual cost because we want to have a positive number if we saved money, right? So if we had, in this case, we expected our costs to be 4.1 million. They were actually 4.12 million. They were actually 4.09 million. So that's a good news story, right? We wound up spending less than we thought we were going to do. And so we go left to right such that if we have a higher expected cost and a lower actual cost, we wind up with a positive variance. So positive 33,000 doesn't mean that they spent 33,000 more. It actually means they spent 33,000 less than they thought they would. So that's how you interpret that. So last time we did these variances, and let me excuse me. Let me remind you that these add back up, right? So if I take the revenue variance and I add it to the cost variance, it aggregates back up to the profit variance. Okay, so last time we did revenue variance, decomposed it into revenue volume variance and price variance, and these each reflect what we were doing earlier. Revenue variance, revenue volume variance is flex revenue minus static revenue. And so that tells us that we, as a result of volume, we earned 102,000 less. So even though we actually earned 36,000 less, where did that 36,000 come from? Well, we had negative pressure as a result of a significant decrease in volume worth 102,000. But then we had price variance, of positive 66,000. So we had a positive impact from an increase in price per unit and a negative impact from having just fewer units. And so when we combine those two things together, right, it adds back up to the parent variance, which is the revenue variance. So on the exam, I'm likely to ask you to do this analysis to tell me, if I were to tell you, hey, you know what, they had a price variance of positive 50,000. What does that mean? And I don't give you any other information. You should be able to say that they earned 50,000 more than they expected as a result of the fact that they got a higher price per unit than they expected to get. If I say they had a positive revenue volume variance, then you would be able to tell me, well, in that case, they earned more revenue than they thought they would because they had higher volume than they expected. All right, so down here in cost variance, right, we had, last time we calculated the just the cost variance. And the cost variance is the result of kind of the overall change in costs. And so we looked at and compared the total expected cost, right, the static cost, minus the actual cost to give us 33,000, and it's a positive. So if I just said to you positive cost variance, you would say, oh, positive, that means good. So what's good when I think about cost? Well, what's good when I think about cost is a decrease in cost. So what you would tell me is, if I told you, hey, with no other information, I said, hey, this firm, this practice had a $33,000 cost variance, positive cost variance, you would tell me, well, they spent $33,000 less than they thought they would. So now we say, okay, we know we saved 33,000. Where did that savings come from? Did it come from the fact that we did fewer visits, or did it come from the fact that we spent less per visit? So that's where we use these next two variances. So we want, for cost volume variance, I'm going to go over here and we're going to compare the volume column, right? So where are the two columns that allow you to vary volume? Well, it's static and flex. So I'm going to subtract, I'm going to take the static volume, static budget minus the flex budget. And I saved, so I had 33,000 in cost savings. I had 157,000 cost savings coming from change in volume. And how about my how did I do in terms of price per unit? I'll take this flex number, because that holds volume constant and varies price, minus my actual, and I can see, oh wow, right, my price per unit increased by quite a bit. So I had a savings of 33,000 in cost. Most of the savings came from the fact that I did fewer visits, but my cost per unit went up by 123,000. And so what this is telling me is my cost per unit increased dramatically, even though my volume decreased. So if I was evaluating the performance of this clinic, I would be concerned about the fact that their prices, their costs per unit of production seem to be rising quite quickly. And they were lucky this year because their decreased volume offset the increased cost per unit. But next year, if we keep seeing this increase in cost, we could see, we may not be as lucky. So down here, we call this managerial variance, as opposed to up here, we call it price variance. The reason we call it managerial variance is we hold our managers responsible, particularly in a healthcare environment. We don't have as much control over volume as we do over the cost per unit of production. And so we refer to the price variance for cost as managerial variance, because we're holding our managers primarily responsible for managing costs, and in particular, managing the cost of doing any one unit. So a question I often ask is, did the managers do a good job? Here's the data. Did the managers do a good job in terms of managing costs? And I give you cost variance, cost volume variance, and managerial variance. And in this case, you could, if you just looked at the top line, you'd say, oh yeah, they did a great job managing costs. But in reality, when you decompose the cost variance into volume variance and managerial variance, and you say, well, you know what, the managers didn't really control the volume, but they do control the cost per unit, you would say, you know what, even though the unit had an overall decrease in cost, the managers didn't manage costs well. They spent significantly more per unit than was expected. And so the answer there would be no, the managers didn't do a good job. So those are the variances that you're going to be responsible for the exam. Each of these variances can be decomposed further. So for example, we could decompose cost variance into fixed variance and variable variance, right? So variable cost variance and fixed cost variance. We could look at labor variance versus supply variance. So we could just keep drilling down and drilling down. And you might do that as an analyst if you are in an actual budget shop to try to figure out where are the problems, where can we improve, where should we put the attention of point the attention of our senior leaders and our managers to try to improve the efficiency of the organization. And so that's what's useful about these tools, is it gives you insight into where you need to push more managerial attention. Okay, so we've reviewed that. So that was kind of a long review of the material we did last time, plus 2 more variances. So I have a U-try here, another sheet. So this workbook is, I didn't say it at the beginning, but we worked with it last time. This workbook is available on Canvas, and it's called Chapter 8 Demo. So you should download that, and you can work through. I'm not going to do this today, but this is another an opportunity to practice in addition to the book problems. Let me stop that. So I would recommend you do that, work through that for practice. I have, for the homework for Chapter 8, I have identified particular problems, and I've told you not to bother with some of the more detailed, more in-depth questions. You can if you want. They won't be on the exam. That's not saying that you shouldn't do it, because you should be. But if you're going to focus your attention, you should do the ones that I've assigned, because I'm not going to go on the exam. I'm not going to go below volume and price variance or volume and cost variance. But that said, I expect you to be able to understand all the kind of components that build up, in particular around capitated, the capitated, that caught a bunch of you on the last exam, kind of caught a bunch of you had not thought through, like how does utilization work? How do utilization rates get calculated? Even though those were problems in the book. So there's that. All right. For the exam for Chapter 8, the old exams are a mishmash. So the old exams, the old exam 3s are a mishmash because I keep changing what I do on exam 3. So exam 1 and exam 2 have pretty much been pretty stable over all 4 or 5 years that I've taught this class. Exam 3, I keep changing. So I used to use 8 and 9, chapters 8 and 9. Then I moved chapter 9 to Finance 2 and brought in chapter 17 because it's really more, chapter 17 is more related to chapters 3 and 4. So some of the old exam 3s are going to be kind of confusing if you look at them. They're not going to be that useful to study from. So I would really spend my effort in preparation for the exam on the Chapter 8 homework, as opposed to trying to find the old exams and look at them. Okay, so that's Chapter 8. I would do that extra set, the U-try. It's just it's the exact same problem. I mean, it's the exact same setup as just with different numbers. So it's a chance for you to kind of see if you can replicate what I've done in class. And I give you the answers so you can just kind of, as well as all the formulas. So it's useful to start practicing with Excel and doing formulas and so forth. All right, so questions about Chapter 8. Okay, so we're done with Chapter 8. So the homework is due Thursday. And we're going to move on to Chapter 17. If you would, see if you can get signed up in your groups. It might be under the people. It might be under people. Sorry?
I had a question. For the exam,
Yes.
do we give it in one group, like the 4 of us, or everybody works it individual and they give their own parts?
That'll be up to you as a group, but you turn it in as a group. And so the group gets the same grade.
Okay.
Okay, so if there's 10 questions on it, Deborah, and you do questions 1 through 3, and the rest of your group does 4 through 10, you get the same group. If 4 through 10 are all wrong, but 1 through 3 were right, you still get the same grade. So the reason I'm giving you as many hours to work on this as I am is to give you the opportunity to divide the work however you feel appropriate, and then hopefully be able to reconvene and review and work together on these problems. So I would recommend, probably some sort of pre-exam study session to make sure that your group has reviewed the material, right? So you're going to have 12 hours, but that's not enough time to learn everything. So I would not be like, oh, I don't have to study because I've got 12 hours, right? Yeah, 12 hours is going to go by very quickly. Particularly if you're trying to coordinate with 3 other people and come to a consensus. So you're going to need to study just like you were going into a regular exam, and have your notes prepared and be ready to go, because those 12 hours are going to go by very quickly when we start. And I'm giving you 12 hours. It should not take, the actual exam itself, if you were doing it by yourself, would maybe take an hour and a half, right? But it's the combination of having 4 people that is going to be the challenge. So that on top of, and then I'm trying not to make it a time sensitive thing, but at the same time, I'm not going to give you as many days as you want to work with. It's a limited amount of time, but it should be more than enough time than you need. But I would, if I were you, I would kind of make sure that my day is clear for that, because you might, I don't know how your process is going to work, but it's due at 9 o'clock at night, one way or another. Any other questions? All right. Well, very good.